This is the first in a series of 5 videos for each set of 6 videos, actually, for each set of problems on the solve exponential and logarithmic functions. These first problems have to do with using the one-to-one property on exponential equations. The key is to find common bases. So on this first problem, 36 and 6, bit of thought, they have, well, this is 6 is 6 to the first, 36 is 6 squared. So we rewrite 36 as 6 squared, and that's still to the x plus 1 power. Now on the right hand side, we have a base of 6, which is what we want, common base, x plus 5. So now we can, with common base, simplify these exponents. This is 6 to the, now power raised to a power, we multiply the exponents, so it's 2x plus 2. And on the right hand side, we don't do anything, it's just 6 to the x plus 5. And at this point, common bases use one-to-one property, and that means then that we can rewrite this, or just go to, if the bases are the same, then we can equate the exponents. That has to be true. So we have 2x plus 2 is equal to x plus 1. Doing a few steps all in one line. I'm going to subtract x from both sides and get x on the left. Subtract 2 from both sides, and I get -1 on the right. Oh, that's an x plus 5. I knew that was the wrong answer. So let me just correct that. My bad right here. This was x plus 5 over here. X plus 5. Copied something down wrong. Let's get the right color. Still not right. That's my color blindness challenge. But this is x plus 5. And so x, subtracting x from both sides, we get x on the left, subtract 2 from both sides, we get 3 on the right. Okay, kind of interesting color combination there. But that is the answer. Going now to the next problem. This is a little harder to see that the common base that we can use, well, 1/2 is 2 to the -1. Let's just start with that. 2 to the -1. 1 over 2. That's the reciprocal property. And then we have that to the c power. On the right, if we can use a power of 2 for 64, then we're in good shape. Then 64 is 2 to the 6th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, 2 to the 6th power. And then that's raised to the 1/2. So we now have common base of 2. Let's simplify those. Go ahead and keep the base here, but this is minus c, -1 times c, and on the right hand side 6 times 1/2 is 3. So we have -c is equal to 3. This is after we have the common base. We can use one-to-one property, and so c is equal to 3. Now, coming here to this third equation, 16 is 4 squared, and we'll leave 4 alone on the right, so we have 4 squared to the x plus x plus 3 equals 4 to the 4x plus 7. Simplify by multiplying these exponents on the left-hand side. 2 times, it's 2x, 2 times x plus 3. Make sure you do completely multiply across by 2. 2x plus 6. 4 is equal to 4x plus 7. All right, and so now we have the common base. We can equate exponents, so it's 2x plus 6 equals 4x plus 7. And here I'll subtract 2x from both sides. So we have 6 equals 2x plus 7. Now subtract 7 from both sides. Negative 1 is equal to 2x. And then divide both sides by 2. So negative 1/2 is equal to x. And that indeed is the answer. You can check it, but we won't at this point. This last problem is the hardest to see a common base. But if you notice, 9 is 3 squared, 4 is 2 squared, and we have 2 and 3 over here, but they're upside down. So let's do the reciprocal property on 2/3, and 3/2. We want to have 3 squared is 9, 2 squared is 4, but we need them in this order, numerator 3. Now, that to the negative 1 is 2/3. That's the reciprocal property. And then that whole thing is x minus 5. On the right-hand side, 3/2 squared. This right here is 9/4. So we're just rewriting 9/4 as 3/2 squared. And we choose 3/2. We want these bases to be the same. Now, that's to the 3x plus 4. Or 3x over 4. At this point now, we can simplify our exponents by multiplying. So multiplying negative 1 times x minus 5. Let's write it this way. That'll be positive 5, or 5, minus x equals, and then 2 times 3x over 4. The 2, when I multiply, cancels with the 4 to be 2. So that's 3/2 to the 3x over 2. And so now we have the equation 5 minus x. Let me change colors because now I'm in the exponent. So I have 5 minus x is equal to 3x over 2. I'm going to multiply both sides by 2. This cancels off, and I get 10 minus 2x is equal to 3x. So adding 2x to both sides, I get 10 is equal to 5x, and then divide by 5, and voila. I've got x is equal to 2.